Okay, so we're solving application problems dealing with quadratic equations. The first thing I need to state out to all you is I cannot solve every different type of application problem. So I just had to hand pick a couple out of my textbook. So the one I picked here is the square of a number minus twice the number is 63. Find the number. And most elementary middle school kids like these kind of like little riddles. So there's 4 steps to solve. Step 1 is reading to find out what we want an answer to. Usually in math, what we want to answer to is by the word find. I want to find a number. I don't know what that number is. I'm not going to sit here and guess. So what I'm going to do is to find this. I'm going to say, let the number. And I know nothing about that number. I'm going to let it equal x. That means every time I see this word number, I can replace it with the variable x. So that's step 1. Step 2 is now to go back and read again and now translate. Just like you do in Spanish class or Italian class, or if you're taking Russian, every English word means something in math. The square of a number. Well, we know the word number is going to get replaced with x. How do you write the square of a number? Well, that means I have x squared, because squaring means I have an exponent of 2. Minus is the subtraction symbol, twice the number. Well, again, we know the word number is going to be replaced with x. Twice something means to multiply by 2, so we would write 2x. In math, the verb is always where the equal sign goes. Is 63. So the square of a number minus twice that number is 63. So there's step 2. Step 3 is to solve this equation. Now we got to look, is it linear or quadratic? It has a square, so it's quadratic, so we'll go through our process. To solve a quadratic equation, we want to set it equal to 0. So we're going to move our 63 to the left by doing subtraction. 63 is not like an x squared or 2x, so I'm going to write these terms in descending order. And we equal 0. Now it's all equal to 0, our quadratic. Which rule of factoring would you like to use? GCF, difference of perfect squares, trinomial grouping. Well, it's a trinomial, and it's easy. It starts out as x squared, so we can do this in our head. We put our 2 sets of parentheses. X squared is x times x. There are lots of factors of 63. 1 and 63, 3 and 21, 7 and 9, yes. So which factors would subtract to give us 2? That would be 7 and 9. I want to subtract, so the signs are going to be different. I want the 2 to be negative, so the 9 gets the negative sign, and the 7 gets the positive. The 9 is the bigger number. Now what I've done is my magic. I went from being quadratic to be 2 linear equations. So let me go over here. I write my 2 linear equations, x minus 9 equals 0, x plus 7 equals 0, and I solve each by doing my opposite, my inverse operation. So now the question is step 4. And this is the step you all skip. You think just because you got 2 answers, you write them both down. You have to read the word problem. The way you answer the question is you go back to the let statement. That's why it's so important. We're going to find a number. Let the number. Now, let's look. Is 9 a number? Yes. So one of the solutions is 9. But if we think, is negative 7 a number? Yes, it is. So now, for this word problem, there's not just one answer, there are 2. If 9 could be the answer, negative 7 could be the answer. How do I know? I'll check it. If I square my number, if I square 9, that would be 81. If I minus twice that number, well, 2 times that is 18. 81 minus 18 would be 63. If I square my number, if I square negative 7, I get 49. If I minus twice my number, well, twice that is negative 14. Well, 49 minus negative 14 would be really adding That would also give me 63. So don't assume because you get a positive and negative answer to always throw the negative out. When we're working real life problems, if we're talking about finding an area, a length, a width, something, a measurement, it cannot be negative. But if we're just talking about finding numbers, numbers in the real world are positive and negative. So this word problem has two solutions. We are now done with Module 16.